Okay, I think this is quite a fun problem to tackle because it's not really hard to do, but it involves some clever algebra, which I kind of like. Okay, so here we have to verify for any value of the constant c, the function p equals cm e to the kt over 1 plus ce to the kt is a solution to this famous differential equation, logistic equation. Okay, so all we have to really do is we have to take this derivative and show that it equals this. So if we can show dp dt equals this, we are done. It's really that simple. So it's really just a matter of applying the quotient rule and doing some algebra to get it into this form. That's all it is. But I think it's kind of fun because the algebra involved is kind of fun. Okay, so let's do it. Okay, so the first thing to do is just to write it as a derivative and apply the quotient rule. So let's do that. dp dt equals, okay, now c is a constant, m is also a constant, and k, these are all constants. So we just keep the cm out front as a constant. Okay, now what I'm doing now is I'm taking the derivative of the numerator and I'm going to keep the denominator as is, as per the quotient rule. So then, chain rule over here, I'm going to bring the k out front, e to the kt. So all I'm doing is just taking the derivative of e to the kt, which is k e to the kt, and keeping the constants out front. And then I have to times that by the denominator as is, and this is just the quotient rule. Again, I'm saying it too many times. I won't say that again. Okay, there we go. Then we have to subtract that from. Now we do the opposite. We keep upstairs as is. Keep the numerator as is. So that's just cm e to the kt. And then we take the derivative of the denominator, which is going to be the derivative of a constant, 0. And then it's something similar over here. It's just going to be ck, because the derivative of e to the kt is k e to the kt yet again, e to the kt. Okay, and then we all of this over the denominator squared, c e to the kt squared. Okay. Now, what we've got to do is we've got to factor out. Now, the key to solving this is to get things in terms of itself. We want to get this mass in terms of itself. So we note that P equals Cm e to the kt over 1 plus C e to the kt. So we want to get things in terms of P. Okay. All right, so what we're going to do is we're going to try and get, take out a p from all of this because we want to get a p on the outside. We also want to get a k on the outside. So let's see if we can take out a cm e to the kt. So I'm going to write it over here, cm e to the kt. And we need to have this downstairs. So we actually have this downstairs squared. So let's take out 1. Take out a 1 plus c e to the kt. I'm just factoring out, just factorizing this. I'm just factoring out this over this because we have 2 of these downstairs. It's squared, and we can find all of this business in here. Cm e to the kt, and we have a k, and look, we have a k over here. So we can just put, because both of these also have a k, both of these terms have a k in them. And we need to have a kp, so let's just pull the k over here too. Now we have our kp, because look, p equals all of this. So I could rewrite all of this as p, which I will do in a moment. So by pulling that out, what do I have left? Okay, so I've taken out a c m k, here's the k, e to the kt, so I'm just left with 1 plus c e to the kt over the other 1 plus c e to the kt. Am I doing this right? 1 plus c e to the kt c, and this is just 1. This right over here is 1, and we have a 1 over here. Okay, I'm just checking. Just making sure I'm doing it correct. Yes, okay, that looks good. Okay, and then minus. Okay, so I've taken out a cm e to the kt. I have to remember downstairs. I'm just separating this into two terms. So downstairs again, I have the 1 plus c e to the kt. And then upstairs, I've taken out a ckm. So here we have ckm. I can just move this k to the side. Ckm e to the kt. And then I'll just leave a c e to the kt. Okay, and again, this looks very much like p. And we need to have a p over m. Okay, so the only thing that this is missing is an m. And all I need to do is times this by m over m, because that is just 1, doesn't change anything. But what it does change is it makes this business, if I move the m into there, p, and it leaves a p downstairs. So this is p, so this is the same as kp. Okay, and I should actually put big brackets over here to make this very clear. So this is kp, excuse the writing there. Scroll down a little. Actually, that p looks a bit awful. I'm going to have to just let me do those brackets again. And my brackets look a bit worse, but my p, I want that p to be a bit nicer. Okay, there we go. So kp, I've just noted that this is p. This is 1, so I can turn this into 1 minus, and if I put this m into here, well, this is p again, but I still have this m downstairs, p over m. And there we go, I've got it. Kp, 1 minus p over m. We've gotten back to the logistics equation. So, yeah, that was fun. It's fun when you have to do a few tricks here and there with the algebra to get things into the form that you want them. And the logistics equation is a very powerful and important equation. It's a little bit of fun with algebra, verifying a solution to the logistics equation.